All right, we're going to look at inequalities in word problems again, but we're taking it up a level. Today we're going to add into the mix restrictions on our word problem. And then we're going to throw in an objective function. And these are both like a lot of really big words for stuff that seems really logical. Okay, so let's look at our first problem. Okay, so we are going to run the canteen. All right, we run the canteen. Sorry, I'm writing this as I go. We run the canteen and we are selling chips for $2 and Gatorade for $3. Does that seem fair? Gatorade for $3. Okay. We need to make how much money? We want to make, let's say, I don't know, how much do we need to make? $100? No, let's make, let's go big here. Let's make $120. That's how much we want to make. However, here's the deal. Can you sell 3,000 things of chips? Do you have that many chips? I mean, you probably went to Costco. I don't think you've got an unlimited number of chips. So we only have so much. We only have 100 bags of chips and, oops, I can't write, 100 bags of chips. And how much Gatorade do we have? And I don't know, let's say 48 Gatorade. Don't they come in cases of 24 maybe? Let's say 30. Seems like a nicer number. 30 Gatorade. Okay, so here's the thing. The first thing we need to do is write our inequalities. So we need to, actually, that's not true. We need to first identify our variables. So we're going to identify our variables, which means all we're going to do is give X needs to be something and then Y needs to be something. So let's go ahead and do that. We're selling chips for $2. So chips came first. Let's make chips our X. Gatorade came second. I'm going to make Gatorade our Y value. Okay, and then the next thing we need to do is write our inequalities. Now, when we looked at this last time, it was pretty straight up to see. So we are selling chips for $2. Okay, so that means we know we need to write that as a 2x, right? Because we're going to multiply 2 times the number of bags of chips we sell. And Gatorade for $3. So we write that as 3y, and we're adding that together because all of that money goes in one place. We want to make $120. Now, you know what I think we meant to say here? We want to make at least, we don't want to make exactly $120, do we? We probably want to make at least $120. So this needs to be greater than or equal to $120. Okay, so this is a good start, but there's more, there's actually more sentence to read, and we need to keep reading. However, we only have 100 bags of chips and 30 Gatorade. So this is one sentence, but what's it really saying? Your chips are your X, and you only have 100. So however many bags of chips you sell need to be less than 100. Can you sell 100? Yes, so less than or equal to. So your X needs to be less than 100. Okay, and we only have 30 Gatorade. So that means we need to write a third inequality that says our Y has to be less than or equal to 30. So just to be clear, we have 3 different inequalities, and that's like totally okay. Because remember, we practiced putting 3 of them on one graph. It's called a system. So we are going to graph all 3 of these. And it's logical, right? Like we can't sell, 5 million, what are they called? Chips. Right? Like we don't have that many. We don't have that much time. You're at a basketball game. It's going to be over soon. So, okay. Now we need to graph this thing. Oh, back up. So these, remember I told you we were taking this up a level? These 2 things that are restricting how much we can sell are called restrictions. So, and a restriction is just something that's limiting you, restricting you, right? Like the actual physical amount of product you have is restricting you. Okay, so we're going to graph this thing is our next step. And remember, we only graph in quadrant 1 because you can't have negative amounts of chips in a Gatorade. And we need to label our axis. So our X is our bags of chips. So bags of chips goes down here on the X-axis because X represents chips. And our Y-axis is our Gatorade. So I'm going to put that there. And that's really important to label those axes. Excuse me. Now, we need to rearrange this first equation. So I'm going to rearrange this, and I'm going to have 3y is greater than or equal to negative 2x plus 120. I'm going to divide out my 3, so I have y is greater than or equal to negative 2/3 x. 120 divided by 3 is 40. Okay, so now, just to be clear, there's 3 things we're graphing. We're graphing this, and we're graphing this. We are going to shade them all. Let's start with y is greater than or equal to negative 2/3 x plus 40. So I'm going to come up here to 40. Whoops. I'm going to come up here to 40, and I don't have a real graph, so I'm just making up a graph, but I'm going to label the important parts. I'm going to go down 2 over 3, down 2 over 3, down 2 over 3, and so forth and so forth. I should really get myself a real graph. This is a solid line. Okay, I'm going to do my test point. So 0 is greater than 40. Is 0 greater than 40? No. So I'm going to shade above. Okay, I'm going to shade. See what I mean? Like this can go on forever, except it can't go on forever because, we said, oh wait, time out. We only have 100 bags of chips. So now I need to come over here and find the 100 for chips and graph up. Okay, well now I need to shade that part. I should have made this a different color. I'm going to make that red. All right, so my bags of chips needs to be less than 100, so I'm going to shade this side. Okay, so I'm shading, still shading. And then I also said that my y needs to be less than 30. So here's my 30. It needs to be under 40. And that's going to come all the way over here. And it needs to be less than. So I'm going to shade. All right, so now, my friends, my question is, what are some possible solutions that you could sell? Well, you could sell right here, right? You could sell this right here. And let's say, I don't know what that is. It's probably like, let's see, it's probably 70-20, right? You could sell 70 bags of chips and 20 Gatorade. Or you could sell, like, right here, 60 and 25. And that would work. So you have these different solutions, but you are limited or restricted. You cannot sell 50 Gatorade. You don't have any. You ran out. And that's okay. So there is an end to this. Now, here's the real kicker. I want to know what your objective function is. So we're going to add another piece to this. The objective function tells us about the totals or the actual amount, okay? So in this case, we're dealing with money. So our objective function is going to equal money or profit, okay? And how do we find our profit? Well, we find our profit with an equal sign because our profit's going to be an actual amount. And our profit's going to be determined by two things. It's going to be determined by the number of bags of chips we sold, which was 2x, and the number of Gatorades we sold, which was 3y. So this is my objective function right here. And it's an actual equal. It's not an inequality, although it uses the same beginning function that we use. That 2x plus 3y, we're using it again. But this time, we want to know how much did we actually make? We know it's more than 120, but how much more? So to use that, I could come over here and take my 70 and my 20, and I would plug them in. So I would say 2x, which is 70, so 2x plus 70 plus 3y, which was 20, right? Because I'm using this, which is just an option. But I could figure out how much I would actually make. Well, 2 times 70 is 140 plus 60, you made $200. So did you reach your goal? Yes, you had to, because we knew you were in the right region. So you were over your $120. You stayed within your $130 minimums. And if you actually sold 70 bags of chips and 20 Gatorade, you would have made $200. All right? So that's the objective function. The objective function just takes your inequality and plugs in real values to get an exact amount. All right, does that make sense? Maybe we'll do one more. Okay, I have a Halloween themed one. Okay, your Graham gave you $100 to buy candy for Halloween, like for her to hand out, to buy candy. Okay, so she says get at least 2 boxes of Smarties and 3 boxes of what's another really good one? No peanuts allowed. Smarties and oh, I know, the one with Kit Kats. I like those. Okay, so you need to buy at least 2 boxes of Smarties and 3 boxes of Kit Kats. Otherwise, she doesn't care what you get. Let's see. Smarties are how much? Smarties are, I don't know, those things are like, they're expensive. They're like $5 each. And the Kit Kats are, I think they're $10 a pop for 1 box. Okay, so the question is, how are you going to handle this? So let's start off with what we said our first step is our variables. So we need to figure out our variables. What do we want to call X? And what do we want to call Y? Let's call X, what comes first? Smarties. Okay, and we're going to call Y our Kit Kat. Kit Kats. Okay, now the next thing we always need to do is write our inequalities and restrictions. And we definitely have restrictions here, right? Because she's told us how many to buy. So here we go. Let's start from the top. Your Graham gave you $100 to buy candy. I have seen a number and I'm going to write it down. $100. Now she's given you money, so this is a max. So everything needs to be less than $100. It can be 100 though. She says to get at least 2 boxes of Smarties. Ooh, trick. It seems that I would like to write that 2 right here. But should I do that? This is like separate. This does not have to do with money, does it? At least 2 boxes of Smarties and 3 boxes of Kit Kats. That has nothing to do with my budget. It's a separate inequality. So I'm going to skip that. I'm going to keep reading. Smarties are $5. All right, now we're back to money. So 5x and Kit Kats are 10. 10y. All right, now, wait a second. I did not use all my information. I still need these 2 boxes of Smarties. So I need another inequality. So 2 boxes of Smarties. So x needs to be greater than or equal to 2. And 3 boxes of Kit Kats. So y needs to be greater than or equal to 3. Okay, time to graph. Okay, so x is Smarties. And y is Kit Kats. Okay, we're going to rearrange this dude first. And I'm going to move my y, I guess. So I'm going to have 100 minus 10y is greater than or equal to 5x. We really need to start doing this the other way because it's a lot faster. Negative 10y is, greater than or equal to negative, to 5x minus 100. Divide out my negative 10, which is going to make me flip my inequality. So now I have negative 1/2 x, because 5 divided by 10 is a half. Plus negative 100 divided by negative 10 is positive 10. All right, so just to be clear, here's what we're going with. We are going to graph x is greater than 2, y is greater than 3, and y is less than or equal to negative 1/2 x plus 10. So we're going to knock this out. Let's start with x is greater than 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. I'm going up to my 10. I'm going down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. You follow me? Okay, it's going to look like this. If I do a test, 0 is less than 10. That is true. Why did you guys just let me graph this in the wrong color? All right. I'm going to shade this. Okay, shaded. All right, now, x has to be greater than 2. So I'm going to come over to my x. X has to be greater than 2. So that's going to look like this. And I'm going to shade that where x is greater than 2. If I put in 0, 0 is not greater than 2, so I'm shading the opposite side. Okay? And then I also have y is greater than 3. So y is greater than 3 is going to be right here. Okay, and I'm going to shade above that as well. So here's what I've got. So now I'm going to go over this extra dark so you can really see what I've got. So here is my area that's going to work. So what are the options that I can bring home to Graham? Like I can bring home, at the very least, I need to bring home 2 and 3, right? Or I could max this thing out and bring home 2 Smarties and 9 Kit Kats. Or, you could bring home 5 and 5, and you'd still have enough for that, and you'd have a little left over. So is she the kind of grandma that wants her change back? Because if she doesn't, maybe you should do that. Or if you really need a lot of candy, this is what you're going to do. So these corners are going to be our maximums. And then this corner is going to be our minimum. Max and mins always happen at the corners, but you can still choose anything in the middle. So if we wanted to write an objective function for this, if we wanted to go that extra mile and write the objective function in this case would again be profit or money, and it would equal, remember what we started with before, so 5x plus 10y. And if we chose, if we chose this right here, This coordinate is 2, 9. So if we plug that in, we would have our profit equals 5 times 2 plus 10 times 9. This is not profit. I'm sorry. You should not listen to me. This is our spending, our money. And then we would have 10 plus 90, which is 100. So that would be our objective function right here. Okay, that's it. All right, I hope that all makes sense. Bye, you're the best.